Hello everybody, this is just a little factoring outline video. I'm just going to jump straight in. There's basically 5 types of factoring. The first is called greatest common factor, or GCF. Okay, I'm going to run through just a couple quick examples. So let's say we have 30 x to the 10 minus, I don't know, what can we do? I don't know, 300 x to the 8 plus, well, let's say 50 x to the 7. Okay, so let's go ahead and add one more term. Minus, let's say, I don't know, 200 x to the power 4. So the greatest common factor is the biggest chunk of stuff that is common to every term, okay? And to show this in a little more detail, what I can do is I can rewrite 30 as 10 times 3, x to the 10, minus, I can write 300 as 10 times 30, x to the power 8. I can write 50 as 10 times 5, x to the power 7. And then I can write 200 as 10 times 20, x to the power 4. And so now, if I look at what's left, like they all have a 10, 10, 10, 10, and they all have, let's count how many x's, 10, 8, 7, 4. So every term has at least 4 x's. And so what I can do is I can take 10 from every term, and I can take 4 x's from every term. And think about what's left, right? If I take away the 10, take away 4 x's from 10. There was 10, now I'm taking away 4. 10 minus 4 is going to be 6. And I still have this 3 left as well. Minus. Take the 10 away, take 4 x's away, the 30's left. Take 4 x's away from 8, you got 4 left. Plus, we took away the 10, we took away 4 x's, so the 5 is remaining. 7 minus 4, 3. Minus, and then took away the 10, so I have the 20 left, and I'm taking away 4 powers of x from 4, so there's no x's left whatsoever. So all that's left inside is going to be a 20. Okay, so that's a GCF example, greatest common factor. Basically, just look at the numbers, look at all the numbers, think about what each number has in common from a multiplication standpoint, and then look at all the terms, and whatever the lowest power of x is the power you can take out. So here's x to the 4, that's the lowest power. I was able to take 4 x's away from every single term. Okay, that's a GCF. Moving right along, the next factoring form is called difference in squares. And it looks like this. A squared minus b squared is a plus b times a minus b. And what I can do to show you that it's true is I can actually do the multiplication. I can do a times a is a squared. I can do a times negative b is minus ab. I can do b times a, which is positive ab. I can do b times negative b, which is negative b squared. And look what happens in the middle. We have minus ab plus ab. That's going to add to 0, leaving just a squared minus b squared. So we know it's true now. And so now, a quick example. Let's say we have, I don't know, let's say we have 81 x to the 4th minus 49 x to the power 6, okay? So the first thing to realize is we have 2 terms, so difference in squares is a candidate. Then we need to recognize that these things are easily squareable. These are easily square rooted. That is, what do you square to get 81x to the 4? Well, you have to square 9x squared to get 81x to the 4. What do you square to get 49x to the 6? You square 7x to the 3, okay? So that's the first part, is figuring out, how to sort of unsquare, take a square root of what's in there. And so there's A. A is in this parenthesis. B is in this parenthesis. So I can apply the formula directly. That's going to be 9x squared plus 7x cubed times 9x squared minus 7x cubed. Okay? We can do it that way. But actually, what will be better is if first we recognize that there's actually a greatest common factor here. There's a greatest common factor of x to the fourth. If I pull x to the fourth from everything, that's going to leave me with 81 minus 49. And I'm taking 4 away from 6, so there's 2 left. And so then from there, I can write the x to the fourth. And now I can apply difference in squares here. So what do I square to get 81? 9. What do I square to get 7x squared? 49x squared. I square 7x. So 9 plus 7x, 9 minus 7x. This is the more factored form. So the point here is always do GCF first. Okay? GCF first. That is absolutely crucial. When it comes to factoring, you always, always, always want to do the GCF first. Okay? Next we have a quadratic trinomial. And this one has a lot of different methods. I will show you my method. So let me write this problem down. 8x squared minus 2x minus 15. Here's how I do this. First, I'm going to take the coefficient of x squared and multiply by the constant. You know what? I don't want numbers that big. Let's do this instead. 2x squared plus x minus 15. Way more reasonable. I want to take the coefficient of x squared and multiply by the constant term. 2 times negative 15, that's negative 30. The hardest part of this whole thing is thinking about two numbers that multiply to give negative 30, but add to the number in front of x. And the number in front of x is 1. Okay, it's a 1x there. So, let's see, what are those numbers going to be? How about 6 and 5, right? How about positive 6 and negative 5? 6 minus 5 is 1. 6 times negative 5, negative 30. Okay, now, in the beginning, we multiplied the 15 by the 2, so I'm actually going to divide each one of these by 2 and reduce if possible. 6 over 2 reduces to 3 over 1, and negative 5 over 2 doesn't reduce at all. The trick is, and it is a trick, but it's fast. The number downstairs is the number in front of x, and the number upstairs is the other one. So in other words, this becomes 1x plus 3 multiplied by 2x minus 5. Okay, so now that's factored. And this is how I do quadratic trinomial factoring every single time. So, if you use a different method, that's fine. I don't have a problem with that. But just understand that whenever you see me doing it, you're going to see me doing it like this every single time. Okay? And then, let's see, there's 1, 2, 3 forms of factoring. I think maybe the last one in this video is the difference or sum of cubes. Okay? And that looks like this. There could be a plus or a minus. Okay? So something cubed plus or minus something else cubed, that factors like this. A plus or minus B. So what that means is if there's a plus here, there's a plus here. If there's a minus here, there's a minus here. Then, whatever this one is, we square it. Whatever sign is here, we change it. So if there was a plus, now there's a minus. If there was a minus, now there's a plus. We multiply the two together, A, B. And then we square the last one, so plus B squared. Okay? So again, this is really two formulas. Okay, I want to point this out. This is two formulas. The first formula comes from reading the top signs, okay? So if there's a plus here, there's a plus here, but a minus here, and always plus here no matter what, okay? And then if you're reading the bottom signs, what's this? If there's a minus here, then there's a minus here. You can't really see it very well, minus. And then there's going to be a plus here, and then again, always plus here no matter what. Okay, so again, two formulas written here in this one expression. Okay, let's do a quick example, maybe a couple if we have time. Let's say we have 125 x to the 9 plus, let's see, let's do something, yeah, well, let's just keep it simple, right? Plus 8 x to the power 3, okay? Once again, there is a greatest common factor of x to the 3. Always do GCF first. That's going to leave 125 x to the power 6 plus, and then 8 with no x's. Now we recognize that this is the sum of two cubes. 2 cubed is 8, 5 cubed is 125, and x squared, if you cube that, you get x to the 6. There's a plus here, so there's going to be a plus here and a minus here, okay? So here we go. X to the 3 multiplied by cubed root now, cubed rooted. So 5x squared plus 2, all right? Then square this one. So 5x squared, if I square 5, I get 25. If I square x squared, I get x to the 4th. Change the sign. Here's a plus, change it to a minus. Multiply the two together. 5x squared times 2, 10x squared. And then finally square the last one, plus 4. Okay? So there's that one. And then very, very quickly, let's do one more. Let's say we have x to the power 6 minus 343 x to the power 12. Once again, we have a greatest common factor of x to the 6, leaving 1 minus 343 x to the 6. And now we need to recognize that these are two cubes being subtracted. So we can apply the same formula that we wrote. So it's going to be x to the 6. And now, cubed root of 1 is 1, minus cubed root of 343 is 7. Cubed root of x to the 6 is x squared. Okay, then square the first one. 1 squared is 1. Change the sign. Here's minus, so it's going to be a plus. Multiply the two together. 1 times 7x squared is 7x squared. And then finally plus, square the last one. So 7 times 7 is 49. X squared squared, x to the 4th. There we go. Okay, so this covers most of the types of factoring. There is one more called grouping. And I'll make a separate video for that later. But I wanted to at least get this out to everybody. So here we go.